Okay, so this talk has the subtitle, The Next Generation of Threat Hunting, but it actually applies to other disciplines that security teams have to tackle, as well as detection engineering, meaning crafting and deploying and tuning detections, or post-breach incident response. And our cyber defenders, as a cyber defender, we often circumvenced by many attackers, and the job is to keep them out of the constituency and keep the organization safe. But this is hard as the organization scales, because the attacker just needs to find one loophole to get in, and then it's game over. So the problem as it grows becomes more and more a data problem, and even though as a security practitioner we'd like to focus on threat hunting, detection engineering, and incident response, we really have to master data first to get the enablement. And it's in today's world, it's everything but easy to work with terabytes or petabytes, and as we're growing, this becomes harder. And the traditional way we've been doing this in the past is with the SIM. We put all our data there, and it had the parsers, it had the search engine, it had detections in some way or another, the integrations we needed, it had the use cases that you could build on top of that, plus it comes with a nice package of dashboards and reporting so that you can also do the compliance check. And if we look under the hood, the SIM is really actually, it's a remarkable piece of monolith. At its core, there's a custom storage and compute engine, and there's on top of that, that's being used by a custom rule engine. Contextual data also needs to get in, user, asset, and threat context, like we've heard in the previous context, that somehow funnels in there to support the detections and also map user entity and behavior analytics in there. So it's one big thing, but it suffers from several issues. And once you kind of want to customize it, it's harder. You have pre-canned analytics. You have often a low bandwidth API. So when you want to get data out and maybe run it through your own new fancy AI ML engine that requires gigabytes per second in terms of processing, that's really hard with all the data you've already onboarded in the SIM. On top of that, it's a proprietary format. So it's hard. If you can leverage it outside of the pre-canned analytics at all, it's questionable, and many of us faced, I think, this. And so there is a problem with high cost, complexity, and I think many of you heard of this. This is also nothing new. It is easy and great at small to medium scale, but as we go larger, and if we also go across, up to nation state, I think the amount of data we have to collect in order to defend our constituency is getting enormous. So this approach is not open, it's not composable, and certainly not unstoppable from a defender's perspective. And so what people are trying nowadays is, okay, well, the next shiny thing is the security data lake. That's okay, maybe that at least has the promise that it has enormous horsepower, infinite I/O, and massive compute. So maybe we can solve our problems there. We still have to get all this data in, and whether a centralized or decentralized approach is viable is kind of a separate topic. Now let's assume we're actually building the same centralized approach. And more abstractly, it's about how do we get the unstructured or semi-structured data from its original form into something that resembles the storage and compute abstractions we have in the public or the private cloud. And so I'm focusing here on mostly the relational engines, and those are great for analytics, but there's also document engines, which are at a different trade-off space, unfortunately, and many of us probably have used the ELK stack or OpenSearch to build their own threat hunting mission out there. But it turns out that we need both analytics and search for threat hunting. But it's hard because we want the power from the analytical engines, but also the flexibility and convenience that we have from the document stores. And that's not easy. It's really hard to solve this. We sometimes see dual stack approaches where people build the hard analytics in the relational engines and then do the full text search, for example, there. But threat hunting requires both. And in the data ecosystem, we are actually a bit more mature when it comes to open standards. So we have a lot of different layers of the stack being standardized, ranging all the way from bottom object storage to the data in motion. So on the top there, I mentioned schema. And this has been changing since 2022. And that's the only part in there that's not really coming out of the data ecosystem, but it's coming up from the need of security to have something interoperable as a common lingua franca, how to basically define events that are conducive to processing with these heavy-duty data tools. And I'm going to talk a little bit later about OCSF in more detail, but there's also other existing schemas that are less so, say, convenient for processing with relational engines, and every SIM has its own. It's Elastic Common Schema, Google UDM, Microsoft ASM. I mean, you can probably name 10 here. And we've done this already in the 2000s. We started off there with Ceph at the time. So this is also an ongoing thing, but thankfully OCSF has some promise here because it's cross-vendor, and even competing vendors are joined the consortium. It's a project with open governance, and so the key idea with open standards is that they promote interoperability and choice ultimately, because we've seen and we failed a little bit in the monolith SIM world where everything was pre-canned. So we figured users need choice, and the data ecosystem has the head start, I think, in terms of security there. You can choose different engines if you want to process data in a structured fashion. There's a lot of standards, and that's not so much the point on finding all of them, but some of them. But we get to this point of openness and composability when we really focus on the standards, and as a corollary, we get the interoperability. But as security practitioners, we need more. This is just, again, we're really just talking about the stuff underneath the iceberg. We're not yet there where we actually want to be. And so far, we've also just talked on a subset of this processing needs. We've just talked about the building blocks. We still have to get the data from A to B, from this raw original form into the structured storage. And that's typically done with something called, ETL in the data world, or data pipelines. It was part of SIM. We had this already, but as we're kind of trying to build on top of, compose something out of different microservices, this becomes a need again. And it's more difficult than you may think. It's not just mapping the fields and parsing the data. There's a lot to kind of do from parsing the binary data, getting it structured, and then maybe one aspect there is just renaming the fields so that they make sense. But you have to also transpose the data in varieties of forms, and maybe even rewrite some of the values, say, to canonicalize URLs and add the schema or something. And ultimately, it needs to validate against the schema. So that's a lot of work. So here's an example of starting with something like a syslog event encoded in Ceph. So you have to unpack that, get the syslog header away, then parse the Ceph out of that, get some sort of, if we want to get from the top, the blue data object to the green structured element where all of the individual atomic data pieces are accessible easily and also can be put in structured storage. That's a lot of work, and that's this orange pipeline there in the middle. This is just one representation of a pipeline. And that's it's a lot of work, and it's a building block that's not that available. But once we have the data, we can, for example, encode it in motion in something that's effectively a data frame, and we can use all the bells and whistles we have from the data ecosystem to do the cool stuff at scale. And in this case here, what it means, like, okay, we take the data. Once we have it flowing in motion, we can attach it to other compute engines that have, say, zero copy approach. The Arrow is a great standard for this, but we can also just write it to disk and use it for subsequent searches and hunts. And so that's where the existing data ecosystem provides us with a lot of options. And so, okay, so this was, we initially thought we just need the ETL piece figured out, but it's actually quite a big piece. There's not yet open alternative building blocks for that. That's something we yet have to build as a community. And we're still doing, those that are trying to scale the operations from a security organization, they're still doing 80% data work. They're not yet at this point where, okay, I can sit in the cockpit and move the levers, and all I want to do is think security. And so specifically, these are functions that are not available as individual, highly standardized services. We have, from a data perspective, we have a great compute engine, we have cataloging abstractions, we have scalable object storage. So we have the building blocks, but there's a challenge in designing the right building blocks for security. And so for the practitioners out there who are working on some of these functions, that's basically my encouraging call, is to really think in terms of, in the same style that the data ecosystem has approached this problem, and work there reasonably well with open standards, and especially focusing on the interoperability. Well, the good news is we have several open standards in security, but we are, I think, far away from pick and choose and getting something that works for our daily needs. So it is a bit of a challenge how to compose a system out of these open standards and create something that suits basically the next generation. And so with that, I do mean terabyte to petabyte or even larger scale of security operations. And that is, I wish I had an answer to that and provide a reference architecture for something. There's many ways you can build some of these. And so just to name a few of these standards here, we have, for example, for threat intelligence, STIX and MISP are both standards that are widely used. And it would be nice to just have one, but we have two. And we are having on the playbook side, for example, Kakao, another OASIS project, also OpenC2 on the response side, another OASIS project that's seeing, still active. But these are not integrated into vendor solutions, right? So in the data ecosystem, if somebody wants to write Parquet files so that you can use any sort of compute engine of your choice, Pandas, Polars, DuckDB, you can readily just grab the data and execute and run some of your queries. But that's not the case in security. So in security, we're still immature. We have the standards. We're a bit behind. And our job is to really create open, and I also mean open source, building blocks that we can rely on, that provide us a well-defined set of functions. And the challenge is not to fall into the trap of what we've done in SIM in the past and build everything into a monolith, because then it's going to be very difficult to leverage the achievements that we've done, that we have already from the data space. And we need those in order to scale to the next generation. So that's the conundrum that we have to solve, especially as builders, to enable the next generation of cyber defenders. That's it. Thanks.
Thank you, Matthias. Any questions in the audience? Not so far. Are you staying for the lunch?
Yeah.
Ah, that's a good idea. So if you want to ask privately, Matthias, any questions, you can do that in the lunch. Meanwhile, I'll give you socks. I forgot them. Let's come. Yes. What size are you wearing? Is it a big foot? Yeah, it's a big one. Yeah. I'll give you these ones. All right? Thank you so much.
Thank you.